Hi guys, let's continue with a problem that's now going to be in 3 dimensions. Typical matric exam question. Have a look at this. A cylinder closed at both ends. Well, what is a cylinder? Let's have a look. A cylinder looks like this. Okay, so it looks like a little tin, a little cup almost. Not a cup, but a Coke tin almost, if you look at that. A cylinder, and it's to have a volume. The volume, now listen to me very carefully, the volume is given as this. What should its dimensions be? Now, remember dimensions, it's got a radius, okay, a radius, and it would also have a height, okay, a little height there, okay. And if we explore the formulas for the volume and surface area, this is what we get. Have a look here. The volume, what is the volume of a cylinder? Just as a matter of interest, let's write it down. Volume is, remember, it's the area of the base, which is this guy here, multiplied by the height. That's the volume. The surface area, now very important with surface area here. What is it? Well, if it's closed, it means we've got the 2 circles. So we've got pi r squared for that top one. We've got the bottom circle, which is pi r squared. So there's 2 pi r squared. And if you remember from earlier years, the curved piece is really, if you open it up, have a look here, it almost forms a rectangle. It does form a rectangle. And remember that this little is going to be the height of the cylinder there. And what do we call this little piece here? That's going to be the perimeter of the circle there, which is 2 pi r. So if you remember, the length times the breadth would be 2 pi r times h. Now those are formulas for surface area and for volume. Okay, now that, of course, you can explore it. I'm not going to go into too much detail with this, but just watch that, those formulas for volume and surface area. Okay, and the volume is given as this. Okay, so if we look at our little cylinder here, there's the 2 circles and the height. And the volume is given. Now, this is important here. The volume is given as 2,000 pi cubic centimeters. Okay, well, let's explore this a bit. Now, they say they want the values of h and r for which the surface area is a minimum. Okay, well, we know we've got a formula for surface area. Let's call it surface area is 2 pi r squared plus 2 pi r h. Okay, and we've got the volume, but we know that the volume is pi r squared h. Okay, that's the volume, and that equals 2,000 pi. Okay, now if you look at this, we've got r's and an h. That's a problem. It's like having, before you can differentiate, you have to have one variable like x's or r's. Okay, now don't go away, watch this. If you look at this, this is a problem, we've got r's. My big problem is this h. So we've got to do something here, okay. We know, let's call the area, we want to get the area in terms of r, okay. So that's cool there. This is no problem there. But the problem is, what do we do with this h? Is there anything we can do to convert the h to something with r in it? Okay, they've given us the volume as 2,000 pi. We know the formula for volume is pi r squared h, which is this here. So all you've got to do is we've got to then, if we can work out, we can do something with h. Well, what I could do is divide both sides by the pi r squared. And look what h comes to. The pi's cancel, 2,000 over r squared. Now that's going to be a lot of use for us here if you plug it in. Okay, so let's see. So if we've got the h there, how can we get the area in terms of r? 2 pi r squared plus 2 pi r. And what is h? H is 2,000 over r squared. What a pleasure. And we can now simplify this and make it easier for us to differentiate. So AR is 2 pi r squared plus, now, 2 times 2,000 is 4,000. And we've got pi divided by r. Okay, because that cancels there. So let's rewrite this on the other page. Okay, so the area in terms of r, if we go and look at that, what is it? 2 pi r squared. Okay, so we write that down. 2 pi r squared plus 4,000 over r. And I think there's a pi involved in that. Let's just check back quickly. There's definitely a pi there. Okay, great. So we can plug that in, and we then now can differentiate. But what is the first thing you've got to do? You've got to first rework the equation in a form that you can differentiate. Now watch this. So we've got AR is 2 pi r squared. Now bring that up there. Plus 4,000 pi multiplied by r to the negative 1. You've brought that up there. Okay, now we can differentiate. So we get the derivative. What is that going to be? 2 pi multiplied by, now think of that as x squared. It's 2 r to the 1. Okay, keep the 4,000 pi. And what do we have? Minus 1 r to the minus 1, subtract 1. Okay, and then what do we do? This gives you 4 pi r minus 4,000 pi r to the negative 2. Okay, put it equal to 0 because we're minimizing now. We've got 4,000 pi over r squared. Bring that underneath. Multiply throughout by, so we have 4 pi r cubed minus 4,000 pi. Divide everybody by 4 pi, and you get r cubed minus 1,000. So if you go into this, you get r cubed is 1,000, and r is the cube root of that. You've got r, you can easily work out h now. You can do that as an exercise. You've got an expression for h, so you can work it out, and you've got your dimensions. Okay, so guys, master these basics. They are challenging, and there are some difficult questions that they can ask you, but it's been wonderful being with you to discuss a few of these things for those of you that are going for the higher symbols. Take care, guys, and we'll see you around on Matrics Uploaded in the lessons to come. Take care.